Hello everybody! We will present you a famous chemical element called uranium. Uranium is the 92nd element of the periodic table with an atomic number of 92, which means that this element has 92 protons and 92 electrons. It belongs to the group of actinides and its chemical symbol is U.
Uranium is the 40th most abundant natural element of Earth's crust. There are 26 isotopes of uranium known nowadays, which means 26 chemical elements with 19 protons but a different number of neutrons. Only 3 of them are natural. The two most abundant isotopes are called uranium-228 and uranium-225, and they are both radioactive. So we will mostly talk about these two isotopes. Uranium was discovered in 1789 by Walter Henry Clapeyron, a Prussian chemist. He found these elements by analyzing a rock called pinch blende.
Uranium-238 has an atomic mass of 238, 92 protons and 146 neutrons. It constitutes 99% of natural uranium. The low radioactive activity and it disintegrates in thorium-234 by alpha radioactivity. Moreover, isotope 238 of uranium is fertile. This means that it gives a fissile isotope such as plutonium-239 by capturing a neutron. The third natural isotope is uranium-234. It is the first descendant of uranium-238 and its abundance is very low.
Then, the uranium-235, these elements represent 0.72% of natural uranium. It is the only naturally fissile element. It was discovered by two German chemists in 1938. What is the principle of fission? There is a fission when after a neutron impact on the nucleus is unbalanced and transformed into two later but still unstable nuclei. It's krypton and barium. This mechanism is called fission products. At the moment of impact with the neutron, these fission products are injected at high speed. They are very radioactive but have a very short lifespan. This gives off both a great deal of energy, but also other neutrons, and it induces a new fission called chain reaction. This chain reaction is controlled. When it's not controlled, it can lead to energy explosion. It is the principle of atomic bomb. For this purpose, it is necessary to have a large enough quantity of materials, called critical mass. Reaching the critical mass triggers the chain reaction, and then the explosion will occur. The chain reaction can also be used in electricity.
Uranium is not only used to produce electricity or an atomic bomb, but is also used as a dye. In fact, natural uranium in oxide form is used to give a green or yellow reflection to glass, ceramic, and faience. Has a component of some conventional weapons. In this case, uranium is used in metallic form, for example, in some tanks. To produce radio elements using a tracer in medical imaging.
Now let's talk about uranium effects. Uranium has dangerous effects on human body. Actually, it is more toxic because of its heavy metal properties than its radioactivity. Biological behavior of uranium in human organisms depend on, firstly, chemical form entered in body. An oxide is less soluble than a nitrate. Secondly, its way of entry in organism, inhalation or ingestion. In case of ingestion of a soluble uranium compound, a few percent is absorbed into the blood and is deposited on the skeleton and kidneys. In case of inhalation, most inhaled particles is deposited in lungs and a small fraction is solubilized into the blood. In both cases, then uranium can stay in skeletons several years.
This pie graph represents the geographical distribution of uranium production. As you can see, 33% of worldwide production comes from Kazakhstan, followed by Canada and Australia. Thank you for your attention. I hope you enjoyed this presentation, and if you have any questions, don't hesitate.